In this lecture video, we will talk about development testing. Development testing includes all the testing activities that are carried out by the team developing the system. The tester of the software is usually the programmer who has developed the software, although this is not always the case. Some development processes use programmer tester pairs. That is, there is one programmer and a tester pair. So both of them work together to test the program. The programmer has an associated tester who develops tests and assists with the testing process along with the developer. It's not done in isolation. For critical systems, a more formal process may be used for testing with a separate testing group within the development team itself, and they will be responsible for developing tests and maintaining detailed records of the results of the test. This is in case of critical systems. Now, during testing or during development, testing will be carried out at three levels of granularity. So, that is indicated here. The first is unit testing. In unit testing, individual program units or object classes are tested. That is, the smallest modules of the program are first tested before you integrate and test the entire program. Unit testing should focus on testing the functionality of that particular object or that particular function or module. At the next level, you have component testing. This is where several individual units which were tested in the unit testing phase are integrated or combined together to create composite components. Component testing should focus on testing the component interfaces because here you may have combined 2-3 units together. Now the units are tested and working fine. Now when you integrate two units together, there is an interface in between them. So sometimes after integration, the component does not test fine or does not give the desired result. So you should focus on that interface which is used to connect the two units because the units were tested to be working fine. At the next level of granularity, you have system testing. This is where some or all of the components that were integrated in the system are further integrated and the system is tested as a whole. System testing should focus on testing component interfaces or component interaction. So development testing is primarily a defect testing process. So the aim is to discover bugs in the software. It is therefore usually interleaved with debugging. Now, testing and debugging are two different things. Testing is with the intention of discovering errors, omissions, or bugs in the software. That is called as testing. Whereas debugging is the process of locating the problems within the code. Where are the problems? That is called as debugging. Finding the problems is called as testing. So debugging is locating problems within the code and changing the program or modifying the program in order to fix these problems. So that is the difference between testing and debugging. Let's now talk about unit testing. Unit testing is a process of testing program components, again, methods, functions, objects, classes. So you are going to only test one small component or one small module or the smallest possible module of your entire software. That is unit testing. That is what we already have defined. Now, individual functions, methods are a simplest type of unit. So when you are testing object classes or these individual units, you should design your tests in such a way that you are testing all the features of that class or all the features of the method or generally all the features of the unit. So this means you should perform these three things. First, test all the operations or functions associated with the object. Set and check the value of all attributes associated with the object. We already know what is an object. We know what are operations of an object. We know what are attributes and their values of an object. and put the object in all possible states. We have seen the state transition diagram, right? Where given a trigger, the object transits from one state or transitions from one state to the other. So you have to put that object or trigger or give input to the object so that it traverses through all possible states. So you should simulate all events that will cause a possible state change. This is how you test individual units, which could be objects or object classes. Okay, so let us consider a weather station object. So here is your weather station object. We have defined this object in our previous module. So you can see it has got one attribute and all these are its operations. So this is how the interface of the object will look like. All right. So it has a single attribute, which is the identifier, and this is a constant that is set when the weather station is installed. There is one constant or an identifier or a value to identify that particular weather station that is held in the identifier attribute. You should therefore only need a test that checks if the weather station is properly set up. So you need to define test cases for all methods which are defined in this third column associated with this objects, such as report weather, report status, power save, and so on. Ideally, you should test methods in isolation, that is independently of each other, but sometimes it's wise to have test sequences. For example, to test the method that shuts down the weather station instrument, that is shutdown method, you need to have executed the restart method. So instead of what the author is trying to say here is, instead of testing each of these independently, maybe you write a random sequence and test if the sequence works fine. So if I call the shutdown method, if it shuts down fine, after shutdown I'm going to call the running method, and again I'm going to test the shutdown method again. Rather than only testing shutdown, I write a random sequence and I test. Let's Now, from where did I get these methods, or from where did I get these states? Where did I get these states? If you remember, this was the state diagram of the weather station. So control, shutdown, running, configuring, collecting, summarizing, transmitting, testing. These were the different states, and these were the triggers or the inputs which are written on these arrows, the labels of the arrows. This was the start state. This was the start state. I think the end state is a little hidden. That's okay. So that was the start state, and you have different triggers which are shown as labels on arrows, and you have different states, and you can see different triggers will transition your object from one state to another. So how do I test the states of the weather station? One thing is to test the attributes, another thing is to test the operations in isolation as well as in sequence, and next is as we saw here, put the objects through all possible states. So I can write a sequence of states and check if the software is working fine. So first I'll go to the shutdown state. After that, I'll call the running state. After that, again, I'll go back to the shutdown state. So is this sequence working fine? What if the object or the system software shuts down and does not start up again? So there is a bug in the software. Or what if it starts up and then refuses to shut down? Bug in the software. So rather than testing in isolation, you write a sequence of states and push your code to work through all those sequences of states and see if your code is still functional. Next, another sequence could be start at the configuring state. What is the configuring state? Then go to the running state, then go to the testing state, go to the transmitting state, and go back to the running state. This is one sequence. So these sequences are not fixed. You can have a variety of sequence, write them down, push your object to pass through those sequences, and then see if your software hangs or gives up on you. Okay, this is another sequence. So in this way, you have to test sequences and trigger the objects to go through different combinations of states. Let's now talk about automated unit testing. So whenever possible, you should automate unit testing. In automated unit testing, what you make use of is a test automation framework. So we have a framework called as JUnit. It's a framework or an integrated development environment with all the required tools like compilers, editors, and all the libraries required. And you have to just use that framework to automatically test your software. So automatically it will give the different input cases. It will record how your system behaves, and it will automatically generate a report. And then you can see if your system is working fine. Even if you want to run the tests again and again, you do not have to manually do it. The framework automates the test for you, saves a lot of time and expense for the developer and the tester. So that is what it does. So usually an automated test has three parts. These are the three parts. The first is a setup part where you initialize the system with the test case, namely the inputs and the expected outputs. A test case is nothing but you write a table or a document where you're testing your, it may have an ID. Every test case may have a test case ID. You write the inputs you're going to test the system with. You're going to write the outputs that are expected. You, for example, if you've developed a simple calculator, you can write different test cases to see if your calculator works. So first maybe I'll pass two inputs, 2 and 0, and another input would be, say, the addition operator. So 2 plus 0, what is the expected outcome? 2. So this way I'll write multiple test cases for multiple operations. Maybe I'll write 2 divided by 0 next time, and what is the expected output. I'll write that, not a number. And maybe I'll write 0 divided by 2 the next time. Expected outcome is 0. And this way I'll write many input test cases that will have the input and the expected output. Then when I test the system, I'll run the software with the input I have mentioned in the test case, and I'll record the actual output. Now I'll compare the actual output to the expected output which I had already written in the test case even before I run the test, and see if there is a match. If there is a match, your system or the software has passed the test. If not, there is a program error or a software bug. So that is the setup part. In the call part is where you call the object or the method you want to test, or you simply run the software you want to test. And the third part, as I said, is the assertion part, where you compare the result of the call with the expected result. So if the assertion evaluates to be true or has matched, then your test is successful. Otherwise, it has failed. So you may also note that sometimes the object you are testing has dependencies on other objects. So the object may work well in isolation, but when you make two objects to interact, for example, if one method is calling another method, then you may have to write tests for these interfaces or interactions. So you may try to use something called as mock objects. So mock objects are objects with the same interface as your actual object. It simulates its functionality. This may be used sometimes when your program is not completely written and you only want to test a part of your software. So the other entities which need to be filled up could be mock objects. And sometimes what may happen is, if you actually execute the program, it might be expensive to do so because the calls or the execution time would be long because it's an actual code. In that case, you can still use mock objects to simulate the task of something that is incomplete or something that is too expensive to execute in real. So this was development testing and unit testing for you.